Hello, my name is Nick Schwartz, and I'm going to talk about the treatment of typical waste found at a brewery with sort of a focus on craft level breweries. That was the focus for the most part in scope on the paper that I wrote. I'm going to go over a brief overview of the brewing process, go through a description of the waste generated at several of those processes. I'm going to go into more detailed description of the waste yeast and shrub, which is the waste that I focus on in my research, and some of the environmental concerns, and give some of the treatment alternatives. So this is a diagram that I made of a typical brewing process found at a craft brewery. I modeled this after the Wormtown Brewery. At the beginning of the process, you have your grain handling steps. Grain is delivered to the grain silo, which is then sent to the crushing step, and then finally to the grist holding vessel. From there, the grains are sent to a mashing tank, where the grains are soaked in water about 160 degrees Fahrenheit in order to extract fermentable sugars. This liquid is now called wort. The mixture is then sent to a lautering step, where the wort and spent grains are separated and the grains are rinsed and finally removed for disposal. After the lautering step, it's sent to the boiling vessel. This is where the wort is boiled with hops for flavoring. And after the boiling the wort, it's sent to a whirlpooling step to rest and to add additional hops. From there, it's sent through a heat exchanger to bring the temperature down and then introduced to the fermenters, where yeast is then added to convert it to beer. After sitting for a few weeks, it may be sent to a bright beer tank to rest and allow the yeast to settle out, add some CO2. It can then be sent through a filtration step, pasteurization step, and then packaging and distribution. So there are multiple steps throughout the process where waste is generated. I'm going to be focusing mostly between the boiling, whirlpooling, and fermentation step. I'm going to give a quick overview of some of the other wastes as well, though. During mashing and lautering, waste is generated is spent grains. These are typically separated and sent out for use as livestock feed. During the boiling whirlpool step, hot and cold break proteins coagulate and fall out of solution. This contributes to high BOD and TSS typical of brewery waste. The fermentation vessels produce waste yeast at the end of the process, and they also contribute to the high BOD and TSS. During filtration, Kiesinger sludge is what is produced. That's made of a diatomaceous earth filter aid. Cleaning process produces caustic chemicals that causes spikes in pH and phosphorus, and bottling and keg washing produce CIP waste as well. So I want to give a brief description of the wastes that are generated between the boiling and fermentation stages. Trub is the name given to the hot break and cold break proteins that develop during the boiling and cooling process. Waste yeast, that is what it sounds like. Yeast is introduced to the fermenters and allowed to grow when in the presence of oxygen and fermentable sugars. As the yeast eats up the oxygen and the conditions become anaerobic, the yeast switches to producing more alpha alcohols. And once there's not enough sugar to consume, the yeast drops out of solution. So here's a chart showing typical strengths of this waste. When concentrated and segregated, you can see that they produce very high VOD, COD, and TSS. On the right is a typical brewery effluent. It hasn't removed the waste, so it's more diluted, but still very high compared to a typical municipal waste of 100 to 500 VOD. So I want to talk about some environmental impacts of these contaminants. TSS is generally a marker for other contaminants, such as BOD. However, a high TSS can clog infrastructure such as municipal sewer pipes or on-site septic systems. BOD and COD are regulated by the NITD's program due to their strong effect on natural waterways. A high BOD discharge will cause bacteria to eat up the dissolved oxygen in the waterway, which can choke out aquatic wildlife and allow for the fermentation of anaerobic bacteria. Nutrients are another concern. Many treatment plants or industrial discharges have limits on the amount of phosphorus and nitrogen that they can send to a waterway. So these nutrient loads can cause harmful algal blooms, which result in the reduction of DO. Many treatment plants have a strict discharge limit, which they pass upstream to some of their industrial users. So I'd like to talk about a few treatment alternatives that are available for breweries to reduce these effluent loads. The first and best option is to side stream the waste and dispose of it along with their spent grains. This is the cheapest and simplest option if it's feasible, but it becomes more difficult as breweries grow. Aerobic treatment is another very common method. It's found a lot in municipal wastewater treatment and also in industrial settings like breweries. It's simpler than anaerobic treatment and has higher BOD removal, but also requires larger footprints and has higher operating costs due to the amount of oxygen required. Anaerobic treatment is becoming more popular due to the possibility of harnessing and reusing biogas to offset some of the operating costs. There are many types of anaerobic treatment configurations. Most common and most applicable for breweries would be the upflow sludge blanket and the aerobic sequencing batch reactors. Microbial fuel cells are something that's kind of interesting that people have been looking into over the past few years. These operate under anaerobic conditions, but they convert chemical energy directly into electrical energy instead of producing a biogas that must be harnessed, stored, and burned. This technology seems to be early in its life cycle. I think it needs more research to make it scalable. So to wrap it all up, breweries have a lot of options when determining how to treat the waste generated between boiling and fermentation processes. There's a lot of treatment options out there, and there's not a one-size-fits-all solution, so it's sort of up to the individual brewery to determine what works best for their situation. Thank you very much.